Okay, hello everyone. Hope you're enjoying the event so far. We have heard from some really wonderful people on topics spanning rollups, modular blockchain design space, network design and architecture, interoperability, and economic considerations of rollups. Some truly insightful presentations. What I want to do now is have a panel on the present and future of rollups. There's a lot to explore here from various angles, and so we thought we'd invite people of different diverse backgrounds to have a richer discussion on where we are and where we are going. So it's my pleasure to welcome three such people from the industry. Here we have Medha Kothari from Variant, Patrick McCorry from Arbitrum Foundation, and Stephanie Dunbar from Messari. Hi to all of you, and so happy to have you on this panel. So, thank you, Medha. Thank you for joining us and making time for this panel, given that all of you are from different time zones. So we really appreciate it, and so let's kick this off. Let's start with a quick intro. So, Patrick, would you like to go first?
Yeah. Hi, everyone. My name is Patrick. I think historically speaking, my research within my PhD in cryptocurrencies started in 2013 on Bitcoin, and then 2016, I ended up doing stuff on Ethereum. And then I guess for many years until 2019, I was a researcher, and then I left the academia and the university system to try to do a startup, as you do. The startup was acquired by Infura, and then eventually after Infura, I joined the Arbitrum Foundation. But during all those years of my research, I mostly focused on layer 2 protocols, or more specifically, how do we scale cryptocurrencies so people can actually afford to use them while still retaining all the nice benefits of a cryptocurrency.
Welcome, Patrick. Medha, you want to go second?
Yeah, sure. Hey, everyone. I'm Medha. So I'm currently an investor at Variant. We're a crypto-focused venture fund. I kind of started off my career in crypto back in 2017 as a software developer. Primarily spent most of my time in the Celo protocol. So I was building out a lot of developer tooling for that ecosystem, a lot of like smart contract SDKs, CLIs, things like that. And now at Variant, I spend a lot of my time looking at different infrastructure protocols. So definitely a lot of research into rollups and things like that. I'm excited to talk more about the panel today.
Thank you, Medha. Stephanie?
Hey, everyone. I'm Stephanie. So I'm also a researcher, been in this space less time than you, Patrick. I jumped in about 2019. I was a technical writer focused on really any kind of emerging technology, helping companies kind of describe, their products and also write grant applications and things like that. By accidentally started writing about blockchain projects and then learned about, the public side of blockchain and, fell in love and went from there. I started my time in crypto, mostly in Ethereum, but with Ethereum staking. So not writing from technical documentation for non-custodial staking protocols. And then joined Messari about 2 years ago as an analyst, started on their diligence team. So was really focused on the nitty gritty details, both on the technical as well as the economic side, trying to become more well-rounded. And here I am on the enterprise research team. I mostly focus on infrastructure, layer 1, layer 2. Hard to pick a favorite, to be honest. I just love talking about, how all this fits together and, just what amazing things we can build with the technology.
Thank you, Stephanie. Now let's go with the first question. And this is a question that I think is very relevant given some of the debate that was happening over the last week or two on definition of rollups and what really defines a rollup. So Patrick, maybe you can start with, so what's your take on the recent debate? What defines a rollup?
Yeah, well, there seems to be two different camps, isn't there? Does rollup equal database, or no, does bridge equal database? And actually most people think I have the opposite opinion. I actually agree with most of the debate out there, so I always think that's quite funny. I think the best way to describe that argument is to step back a bit and think, as an industry, what are we actually trying to build? And then how does this relate to rollups? So the entire point of a blockchain system is that a blockchain provides one purpose. I give you a copy of a blockchain, and you can compute a copy of a database. And that's all it does. This allows anyone to compute a copy of the same database. So then the question is, how do we all agree to the one database and to the one blockchain? So then anyone in the world can download the one true blockchain and then compute a copy of the same database as everyone else. And there's two ways to do that. One is, you could deploy your own consensus protocol, build your entire ecosystem, build your peer-to-peer network, something that looks like Bitcoin or Ethereum, get all the participants together, get your honest majority, get all the stake in there to defend the system. So you could do that. That's one approach, build an entire ecosystem from scratch. And that's very, very hard to do. It's no easy feat. It's a Hercule feat. The other approach, if you want to, instantiate a new database, is to say, well, can we not just reuse that system that already exists? Could we pretend it's like a sort of like a public bulletin board where as long as we can post the data there, then anyone in the world can pick up the data. They can, parse it according to some set of rules, and then they can compute a copy of the database themselves. And that's basically the rollup. The purpose of a rollup is to create a database for whatever purpose that you want. And the way we all agree to that database is that we just post the data somewhere else, like Ethereum or Bitcoin, like ordinals. And then everyone can say, okay, well, I know the data is there. The data is ordered. I know the rules. I can process the rules. I can get the same database as everyone else. So at the heart of it, that's all a rollup is. It's just a database where the data is publicly posted. And we've known how to do this for at least 10 years. So the early examples were like Colorcoin and Mastercoin. I don't know if you guys remember that. It was the issue assets on top of Bitcoin. But the Bitcoin platform could not enforce the rules. It was just used as a data availability layer where we could post the data there, and the software client could then parse that because the software client was aware what the rules were. So we've known how to do that for 10 years, and it sort of died off for a long time, maybe 6, 7 years. But they recently got popular, and this sort of gets to the heart of the debate because we now know how to build better bridges. And this is like the second half of the debate. So normally when you use a cryptocurrency system, let's just say I'm on Ethereum and I want to move my assets to Coinbase, there's a bridge in the middle. I lock my funds up, I give them the Coinbase, Coinbase protects the funds, and then it shows up in their off-chain database. So the whole point of the roll-up movement today is to build a validating bridge where I can take my assets on Ethereum, move it onto an off-chain system, something like Arbitrum or Optimism or Starknet. But at the same time, when I move my funds to that system, I don't have to trust the operators of that system. The entire off-chain system could be fully corrupt, malicious, wanting to steal my funds, and the bridge will protect my funds. And that's basically at the heart of the debate. You have this off-chain database, and then you have this bridge that then protects your assets when you bridge onto this off-chain database. And all of the debate is really being focused on, does the bridge define the database, or does the community define the database? And that's sort of at the heart of the entire debate. But maybe that's a bit of a long answer, actually, so I apologize.
Well, I think
but that's basically what the
it sets the context very clearly. And so Medha and Stephanie, what are your take on this? Do you feel like
Yeah,
go ahead, Medha.
sorry. I think Patrick had an incredible explanation of what blockchains and rollups really serve to do. And like adding on to that, for me, it really comes down to semantics. I think it really depends on what you think is scaling. In the most like simple sense of the word, for me, scaling Ethereum means dApps being able to use Ethereum native assets, so like ERC20s, ETH, etc., on different block spaces. And essentially scaling expands block space by allowing new execution environments to be built on top of Ethereum, which can then be made available to all of the ETH-based applications. And I think rollups unequivocally do that. So that's kind of like the side that I land on.
Stephanie?
Yeah, I'm kind of in the same boat as well. I think at the end of the day, right, like there's also that bit about social consensus that, the community could get together and they could then, move the bridge elsewhere. But I feel that would be, it's incredibly costly. And at the end of the day, you could say that there's social consensus behind everything, right? So I fall more in the camp that the bridge is really important and is, a big part of the rollup. But I do see the other side as well. But in terms of scaling Ethereum, I know there was, that argument about does Jersey scale New York? And I thought about that a little bit as well. And I also understand that perspective, but I think I was hearing in a Twitter Spaces about this idea that, well, if you add a new district in a city, that does scale the city. So I think that at the end of the day, although a rollup at this present point in time might not be scaling the base layer of Ethereum, there is the future in which we have dank sharding, other upgrades that will, that will change in order to, do the Ethereum centric roadmap and move forward and scale the entire ecosystem. So when we get down to semantics, I can understand how rollups don't technically scale Ethereum at this given point in time. But if you look at the long term, I believe that it does. I believe that they do.
I mean, a follow-up question would be, again, about semantics mostly. Should we consider rollups as L2s or layer 2s? Patrick?
I think layer twos are a terrible way to describe all of this innovation. I mean, it's just a word that popped up because of the Lightning Network back in Bitcoin, and we've sort of hijacked it. And I feel like because of that, people get confused about what we're actually building. And as I mentioned, all we're really building are bridges to other blockchain systems. And so it just really comes down to what are the trust assumptions when you use that bridge, and what are the trust assumptions of that other off-chain system as well. So yeah, I use the layer two phrase because it's a buzzword that everyone understands. But I think it's a really bad buzzword because it's just confused. Because like even like layer two, you can like let's just say it's like Starknet's Palladium, where you have this trusted committee that keeps the data off chain. Is that really a layer two? Or there's a trusted committee versus another bridge that just relies on a trusted committee to move the funds back and forth. So yeah, I think it's a terrible phrase because it sort of confuses people on the security of the system.
One. Totally agree. I mean, I think all of this is just serving to expand block space. So I tend to just use the word block space.
Stephanie, I suppose you as well.
I agree. I think it's so hard now because it's been in the popular discourse for so long that like if we start to change the words like too drastically, like as we've seen, it kind of gets everybody riled up. But I do agree. I think in the far future, this idea of the kind of parent versus child relationship is going to change as the ecosystem expands and we see more rollups. But it is hard to change the terminology at this given point in time.
Okay, so now moving away from roll-up world and the modular world, if you go back to what people often refer to as the monolithic world, right? People, I mean, at least in the crypto community, right? It's pretty kind of standard now that they all agree that modular architecture is fundamentally a better design. But what are the benefits of a monolithic architecture that people working in the modular space should definitely acknowledge and maybe should learn from as well? Any points and characteristics? Go ahead, Medha. Yeah.
Sorry, I was going to say I can just jump in with one example and then would love to hear everyone else's. I guess one of the best parts of modular structures, in my opinion, is that you have specialization at each part of the stack, right? But with that, you're basically introducing all of these dependencies at every layer, and that increases kind of like the exploitation risk of every part of the stack. So in a way, monolithic structures, you kind of know exactly what you're getting. And I think because
as well.
Sorry?
And new trust assumptions as well. So for example, if you're using a new DA layer with certain trust assumptions, then you're kind of following that as well.
Exactly. Yeah. So I would say monolithic architecture definitely has like some level of trust minimization. And because there's less experimentation happening, I guess you could maybe assume that there's like less mistakes or like there's one thing that people are working on. So those teams are spending years building out those layers of the stack versus, again, with kind of trusting different modular parts of the stack, you're trusting that each one of those are acting perfectly, and they might be totally independent actors. So
I think I would just add to that. I had a different thought in terms of what the modular world I'm going to jump to my second thought. Something that I've been thinking about a lot is about infrastructure concentration in general. So although when you add different pieces to the stack, you have the potential for there to be failures of the different pieces, there's also kind of this unforeseen, underlying stuff going on between, any system, including monolithic structures. So, where all the nodes located, where's the majority of the stake, how many clients are they using? And, that's fundamental to any blockchain. But I think that people don't realize that, I think that at the end of the day, it's when you're just scaling one system, it can be just as dangerous as scaling, I think it's actually less dangerous when you have the different components because you have the optionality and there's people that are going to be building different things and thinking in different ways and using different infrastructure. So I think that it can be seen as a benefit as well as a kind of a drawback that there are different, pieces put together. It can lead to some additional issues, but also protect against other kinds of failures as well.
Yeah, maybe just to jump in, I've been trying to think how to answer this one. It's quite tricky. Because I sort of, historically speaking, I lived through the block size wars. I sort of saw the conflict amongst the community. And at the heart of the block size wars was because we didn't understand anything about modular systems. We just assumed that you only have a monolithic architecture, and that was the only way to scale these networks. And so either you had this trade-off in decentralization, do you make the system more affordable with bigger blocks? bigger blocks, cheaper transactions, more users, but then you reduce the operators of the system and people who can verify the system. On the other hand, you have small blocks. I can run this in my Raspberry Pi and everyone can verify that it's correct. But then this is a very expensive chain, it's a whale chain, and it's not decentralized in terms of users because it's only useful for whales. And that conflict was very toxic because we just didn't understand the design space of, there is a third way of actually just modularizing out these different problems. Maybe the benefit of the monolithic approach is really bootstrapping. Maybe that's the best benefit. You want to, most of the successful projects in our space got code out as soon as they could, and then they let a community emerge around it. If you try to start from the beginning to build your ivory tower, then you're going to fall behind the market because it takes 5 years to deploy, then no one cares after that point. So maybe the monolithic was useful for people to bootstrap a project, see if it works, then afterwards they begin to modularize it. But I think if you remain as a monolithic project, then you just end up in this toxic war because you can't achieve the stated goals of the project because it just doesn't allow you to achieve it. That's the Bitcoin problem, which is such a shame.
Talking about...
Yeah, I think that's good.
Go ahead, Medha.
Sorry, I was going to just add one more. I think that was a really good point. I think similar to that, different economic models might also lead to very different incentive structures. So imagine if each part of the stack has its own token. So the DA layer, execution, etc. So beyond the fact that coordinating all these tokens might add complexity, you also just have the fact that these tokens might have totally competing incentives. And so one of the benefits of the monolithic approach is that you don't have to deal with this at all. And it might be more capital efficient. This is a big question mark, but I think it's one thing to think about.
Yeah, and actually maybe just to jump in, because I know people are listening to this, when we have they may not actually know what a modular architecture is. So, there's basically three, I like to think of three different layers. You have the data availability layer, which is basically saying, here's all the data blobs, and here's the total ordering of the data blobs. Given the data blobs, hopefully we can then compute a copy of the database. Then you have the execution layer where we take the data blobs, we execute them, and then we actually, compute a database itself. And then the third one is sort of this settlement layer, which is the Ethereum layer, and then so I'll actually get that in a second. The settlement layer basically is the database that records all the assets. And it should really be minimal execute. Well, there's actually a debate whether the settlement layer should just be data or it should be data plus a little bit of tiny execution. So the Ethereum roadmap would be that Ethereum serves as a data availability layer and a settlement layer, then the execution layer are the rollups. Something like Celestia would have just a data availability layer, then an execution layer on top, or a settlement layer on top, and then your execution layers, the sovereign rollups. Ordinals would be the same, for example. And so we're even in the modular space, we're debating on how modular it should be because you lose some nice benefits if you really do distinguish the data and the settlement layer. And that's something that's going to be tested soon with the launch of Celestia. So I'm really excited to see that happen versus something like Ethereum.
Talking about bootstrapping off, it's easier to bootstrap, it's a monolithic network or chain. Talking about that, it's I guess an equivalent of that would be an app chain, right? Model for example, in the Cosmos space. And Stephanie, you did write quite a few articles on this, at least one article I remember that I've read. What are your thoughts on rollups versus app chains, right? What are the benefits of building a rollup directly for your application versus building a monolithic app chain, for example, using SDKs like Cosmos?
Sure. So app chains, born out of the Cosmos ecosystem are this idea of having an entire monolithic blockchain for one usage. So you could have, Osmosis is a great example of, a DeFi specific chain. You could have another infrastructure specific chain. I think DVPN does decentralized VPNs. And so it's in the Cosmos world, it's kind of a collection of these, sovereign independent chains, and they're connected through, a message passing layer, which is IBC. So the difference between an app chain and a rollup, the biggest difference is obviously an app chain is a full monolithic structure. So you have all of the layers, put together. You have, a validator set, and that's, I think one of the biggest detriments to an app chain is, having to bootstrap that validator set, like we were talking about before. It's a Herculean effort, I think you said, Patrick. So super challenging, right? And you have to attract, a good number of distributed, individuals to operate your chain. And that can be really challenging. So the difference between, a rollup or an app-specific rollup and an app chain is that you have an app-specific rollup can be, specific to a certain type of, need, so DeFi or VPNs or whatever it be. But you're abstracting away, you're using different infrastructure for that base layer. So your DA and your consensus is, outsourced outside of your system. That way you can only focus on your execution environment. You don't have to worry about bootstrapping that validator set. And you just have a little more flexibility there in terms of, also you can, be a part of a settlement layer. So if you're, if you're an L3, sorry, I'm going to use the terms, an L3, on an L2, you share the benefits of sharing a settlement layer with other rollups. And that would be the primary differences. I think in terms of what is best built on a rollup as opposed to an app chain, I think it really comes down to, developer preference. Like what are you looking to do? Do you really want to build that base level infrastructure? Do you want to have that customizability right to the base layer? Or do you want to, outsource that and focus more on your execution environment and focus on the benefits of being, just specific, kind of the what's the word? The simplicity of just operating in that space. I think I'll pass it off to Medha. I think you probably have a lot of good ideas about what would be really specific examples of, an app or a rollup or an app specific rollup as opposed to an app chain. But for me, I just feel that it comes down to the developer preference, and you could go both ways. It's just about kind of thinking about your specific application first and then building from there.
Yeah, totally. I think Stephanie did a great job giving an overview of like why you'd want one over the other. I think for me, like an interesting use case that pops out for kind of the opposite, like why an app chain versus a rollup, is when you need to really have fine-grained control of like security in the consensus layer. So a good example of that would be like an application where like the regulatory boundaries are super, super strong. Like you need to know like who your validators are. You need to know what the rules are to like pass any sort of like transaction validation, etc. I think it makes a lot more sense to build an app chain rather than a rollup, because you can have control of every part of the stack, kind of like what we were talking about with the previous question.
Patrick, anything to add?
Yeah, I was just trying to like process what they were saying. They all made really great points. Maybe the way I like to look at it is sort of, so I know we're using the term app chain, but basically what we're saying is we want to build our own entire network and then obviously pass messages using IBC, for example. And as mentioned before, that's sort of like a Hercule effort. Those systems are secure because you assume an honest majority of the participants are honest, effectively, and they're willing to protect the safety of the system and the liveness of the system. And that's a pain in the ass to do, to be honest. It's a lot of work to put that together. Where what's really nice about a roll-up system is that what we're really doing is saying, all these systems do need this ecosystem, this honest majority, this consensus protocol to run the system. Basically, that always needs to exist. A roll-up just takes something like Ethereum or Bitcoin right now, and they just take that as a black box and they say, okay, we've got this now. We can just use Ethereum. It already exists. It's done all the hard work for us. Then we deploy the bridge, and then the way the bridge can be set up is that we just need one honest party to protect the system. As long as one honest party can step up, they can stake, they can participate, then the entire queue and all the funds are protected as well. And so it really just comes down to this path of least resistance. Do you really want to deploy your entire whole network, or do you just want to set up a system where you need one honest party that could be anyone in the world at some point? Right now, obviously, it's still being built, but long term, it could be one honest party that steps up, even if the operators of the system are malicious. And so it just becomes this technology stack. Long term is like an SDK. I want to deploy a database. What do? I get the code. I deploy the bridge, creates my database for me. I have a sequencer, may have one or two executors, but it's open, it's permissionless. Then anyone can step up to do the hard work if that's necessary. For me, it's just, again, least resistance. This is an easier stack to deal with. And you can imagine thousands of these emerging because it's just way easier for people to do. And now there's lots of roll-up as a service companies. Even Outlayer, again, is like a roll-up as a service company, because it's way easier for you guys to write software to deploy this versus creating unique networks for everyone. So it's just way easier to deal with. I don't know.
That's true. It's much easier to deploy a rollup as opposed to finding, I don't know, even 100 validators, let's say, if you want to have for your apps. It's pretty complicated and time consuming. And then, you have
exactly.
to incentivize them as
100
well.
And no, just your point, though, that's a great point. If I want to set up an op chain, maybe I need to have 100 validators. I have to go source these people initially and bootstrap it, or you just have one honest party. It's just easier, isn't it? Just a lot less.
Indeed. That's it. Yeah, go ahead. Go ahead, Medha.
I was just going to add that, a lot of these, like a lot of the no code, rollup deployment interfaces, I think like the goal is to like get a rollup up and running in, 10, 15 minutes, which is just fantastic.
Yeah, let's talk about that. So, of course, Autlay is building a rollup as a service product, and there are other parties and vendors and builders out there that are building similar products. Some of them are, I'm not sure if they can be called rollup as a service, but more like some people offer this SDK model, and the others offer kind of a managed service model, like a SaaS model. But the main question, like at least a common criticism that I often hear from some people, is that there isn't enough demand for application-specific rollups today. So what are your take on this? Do you feel like there's demand and it's just that you guys don't have it, or is it like it's still building and it will take a few years for the demand to really come to a place where it will be noticeable?
Yeah, I love this question. I think it's a bit of both. Like there's like the chicken and the egg problem. Like, yes, like right now, maybe the demand isn't there yet, but I think part of it is because it's not super easy to stand up a rollup right now. So like to Stephanie's point, the reason why like rollups as a service exist is because not every team has the developer bandwidth to like manage all of these things. And also like we shouldn't have to reinvent the wheel every time, right? You can't expect like a consumer founder to have to keep up to date with all of the research happening at the infra layer. It's like not a good use of their time. But I've definitely seen in my portfolio, for example, people are very much thinking about how to scale, how to like control their own block space, how to look at different things like MEV as a business model, et cetera. And all of those things kind of require specific knowledge at the infra layer, which if a company is willing to kind of stand up and make it easier for them, I think definitely people are going to use them. So I think abstraction is the key. So once these things proliferate and once people understand why they should be using their own block space and kind of controlling their own rollups, once that idea launches, it'll be a lot easier and that'll kind of increase demands for rollup as a service products. But I'd also love to hear your case for this, Amrit, since you're thinking about this every day. So at some point, would love to hear your thoughts.
Yeah, sure. I can go ahead. So, I do feel that there are certain types of developers, or at least companies and entities out there that definitely do not want to go and build everything from scratch, right? Even SDKs, because that's not their expertise. Like it or not, they still have to go and understand sequences and things like that, right? And so what they want is they want to outsource the entire stack to someone else and say, guys, why don't you go and manage this for us while we go and focus on our game development, for example, right? Because that's what their core expertise is. And so in those cases, we have seen people coming towards from the gaming industry, and people are building around experiments around SocialFi to come to us and say, okay, guys, we want to have our own chain, because historically too, right? Games have always tried to build their own infrastructure, right? Because look at Axie Infinity. Initially, it was on Ethereum, and they went to do their own thing. More recently, Ronin is a good example of an app chain for games. Game developers are definitely very keen on building app-specific rollups themselves or using infrastructure provider. DeFi has certain restrictions. Many of these people feel like they would miss on liquidity. It's not good to have sitting on your own rollup and things like that. Maybe that will change with better bridges and so on. I'll stop here, Stephanie, if you have anything to add.
No, I guess I would say I really agree with both of your points. And I also just think that, I guess to add to that, there's just going to be so many different people that want different things. And now that we make it easier, the more abstraction we have and the more, rollup as a service kind of products we have, the easier. I think before you were kind of talking about how there's the rollup SDKs and kind of the no code deployment. And I think I'm really curious to hear what Patrick says about this specifically, but my original post, I wrote a piece about rollups as a service, and I had kind of grouped them all together. I put SDKs and sequencers as a service, as well as no code together. But the more I think about it, and I think there was a debate on Twitter about it as well, I think that SDKs probably don't fall into that definition of rollup as a service, because a lot of these SDKs are, open source or with, permissive licensing, and they can just be used. And so rollups as a service providers can build on top of them. And I think, Arbitrum would be an example that, and correct me if I'm wrong, but the way that I kind of looked at it with the licensing model where you can freely deploy anything with Arbitrum Nitro on top of Arbitrum. But if you want to deploy, roll up with Arbitrum Nitro elsewhere, you're going to have to, make an arrangement with the DAO or get the DAO to, agree to that. And so I thought, there has to be some incentive for the DAO to want you to do that. So in some ways, you're kind of treating the use of the code base as a service. So curious to your thoughts on that, Patrick.
Yeah, that's great. I mean, that there's sort of two ongoing questions now, isn't there? So let me tackle that one first around the license. I think that's important. No, that's really important. So basically, it really comes down to the heart of whether companies can offer rollup as a service, because if they can't get the license to the software, then they can't offer the service, can they? And this is something that the Arbitrum DAO really needs to deal with at some point. I wrote a blog post a long time ago before I joined Arbitrum, and what I was really looking at was sort of the licenses of rollups. Like the problem with the business source license, and I'm going to say business source license for now, is a lot of startups don't want to go and interact with a company in order to get a license. So then they deploy, the actual type of software. That sucks from everyone's perspective. We don't really want gatekeepers to have to deal with this. On the other end of the spectrum is sort of the Apache license and the MIT license. Is that what you can also end up fostering is that someone might take your code and compete directly with you, and then harm the ecosystem in a sense. We sort of saw it with Sushi and Uniswap, and then Uniswap pioneered the business source license. That also sucks because if someone takes your code, deploys it, they don't feed back into your ecosystem, then that sucks for Arbitrum, doesn't it, or any other network or any other project that's building software. So I really like to see the Arbitrum DAO deal with, and it's up to them to deal with it, is a ecosystem license. Where as long as you satisfy some criteria, maybe you share some of the revenue back to the DAO, then you're free to take the code and deploy it any way you want in a layer 2 format. We have some evidence that, at least for the Optimism upstack, like the base protocol, or Coinbase base, and the other, I forget the other company now that's doing it, but they've all agreed to do a revenue share with Optimism, or at least the Optimism Foundation, whatever legal setup they have. And that's cool, that's something that could be incorporate into a license and then incorporate into the SDK, and then that's how they launch L2s. So I think that's definitely a problem for the Arbitrum DAO, and I would love to see them start talking about that, because it's their decision to do with the Arbitrum code that they want to do now. So that's maybe the answer to the license question. Then the other one is sort of the original question was sort of like, why should we care about these systems? What are the use cases? Are we just too early with them? And I think there's two solid use cases you can think of. One is we want users to interact on the rollup itself. And I think from a user's perspective, users don't care. Users don't really care who custodies their funds, but operators do. If I'm a trendy startup today and I want to compete with Coinbase, can I really replicate their operational security to protect billions of dollars? Now, that is how they protect their assets, even Binance as well. I think they have like $60 billion or something crazy like that. Setting up the human process to protect those funds is very difficult. What's really nice is rollup as a service, or as a software stack, is that I can take the code, deploy it, and then the software protects the funds for me. So as a trendy startup, I no longer have to worry about custody or protecting users' funds. I can just actually focus on the service that I want to provide. And I've seen this already with like Loopring, DYDX, and other exchanges like rollups. And obviously Coinbase is now doing the exact same thing. They've realized, we can deploy a rollup and we don't have to protect our users' funds now. We can have Coinbase custody, then we can have a rollup that provides financial services like trading and swapping and loans, etc. So I think that's like one very user-oriented approach. And I think it's the operators that care more about that, because it's way easier for a startup now to compete with Coinbase. The second one, it's more from the perspective of smart contracts that live on the blockchain already. So maybe they already live on Ethereum, but they want to get some external information. It's like an Oracle service, a bit like Chainlink or maybe the Subgraph. when you think about these bridges, at the heart of it is that they just pass messages. You can pass messages from Ethereum to the off-chain system, or from the off-chain system back to Ethereum. So in an ideal world, because I'm sure people know about Subgraph, where you can index data and then query it and get a result. It'd be really nice that if I was a smart contract living on Ethereum, I could ask the Oracle for data, the Oracle could respond to me, but I have confidence that a certain algorithm or process was executed on that data. So I can get confidence about how the data was manipulated. The source of the data obviously depends on, garbage in, garbage out. You always have that issue. But at least I have confidence about the execution on that data and that the result could be correct. Where today you just rely on certain parties to attest to the fact that it was done correctly. So there are two use cases I see. You could build a much better subgraph, or you could build a rollup that targets users, and that'll be more for operators probably than the users themselves. So sorry, I know that's a really long answer, but I think that's sort of how I look at it today.
Let me give the follow-up question to Stephanie, this one, because I think she mentioned about SDKs, shared sequencers, and so on, right? So do you feel like for some of these, for example, shared sequencing to be successful, you need a lot of rollups? Do you agree with the statement?
I think there certainly is. I think that the success of rollups as well as sequencers is obviously coupled, right? You can't really have one without the other. I mean, you can have a centralized sequencer, but which is also an option. But I'm sure a lot of projects are not going to go in that direction. They're going to want either their own decentralized sequencer set, or a shared decentralized sequencer set. So I think that there's a lot of network effects. Like you get a lot of benefits when you share a sequencer set. You have if you share a data in a sequencer set, you have a lot of composability benefits in terms of bridging and atomic transactions even. So I think it will be really beneficial for some of these shared sequencers to have a lot of rollups they're plugged into, and it'll be mutually beneficial for both. The thing is that I don't think anyone has really modeled it out yet, unless I'm wrong. But there's probably going to be a limit to which you can share a sequencer set. Eventually, you're going to have too many rollups, and the load will be too much, if I understand correctly. So at the end of the day, I think that there is space for a variety of different shared sequencer sets, and it's also good to have that friendly competition. And it's a positive sum game in the end. You don't need to have just one sequencer set that everybody uses. But if you join a sequencer set, you want to be a part of that ecosystem and have those composability benefits. And so I think that, sorry, I think I'm kind of blanking on the original question. I think the question was whether they would be successful.
The question was,
I think you answered it very well.
No, you right. So the question was mostly around, so you have these, I guess, services or service providers today, like shared sequencing networks or interoperability solutions out there. And of course, they can be successful with, let's say, a few rollups out there, but they become even more successful when you have more and more rollups, right? So, for example, the grand vision of every smart contract is a rollup, essentially. Then you have these interoperability solutions or shared sequencing really become the biggest, I guess, the leverage on these, the growth of rollups in general, right? So the question was that, do you agree with this, or do you feel like they can find other ways to tap into the consumer base and user base?
Well, I mean, teams are smart, and if they needed to pivot for some reason, rollups didn't work out, and they didn't want to be sequencers, they wanted to be validator or something else. I'm sure they could pivot and do so. But yes, at the end of the day, right, the shared sequencer networks need the rollups to be able to succeed. But I do really feel that the ecosystem benefits that you're going to get from these shared sequencers are going to really create all these ecosystems that we haven't even seen yet. So I'm super curious to see what happens. But I think that there's a huge need for it, especially right now as we get closer and closer to seeing a lot more live rollups.
Medha, any comment on interop and rollups?
Yeah, totally. I was actually going to mention this later, but I think I would really hope that there's more of a focus on this in the future. Like, I'd love to see kind of a greater emphasis around like interoperability and shared liquidity on all of these like shared rollup infrastructures. Because, for example, in an ecosystem like Optimism's OP stack, I think shared sequencing could really help something like interoperability, where you're making sure like Base's ETH is like easy to access with just like normal ETH and all of the other like optimism chains, etc. Right now, that isn't like super easy, actually. Like the bridging UX is not great. So I think that this is a place where a lot of really smart teams are working on shared sequencing, and I think this will help a lot. I also think around value capture, this idea will be really helpful. So shared sequencing kind of opens up a huge possibility around MEV. And so with more research on shared and decentralized sequencing, I think a lot of these L2s or block space companies will be able to think about value capture better, because right now, most L2 tokens like aren't really doing much yet. They aren't capturing value in a way that makes sense beyond like governance. And I think shared sequencing is kind of like a potential avenue, like a solution for that.
Patrick, any thoughts?
I think both the comments are really good. I'm just trying to think what I can add to it. I think it's really important to distinguish what the sequencer is supposed to be doing. Again, for people listening to this, they might not actually know what the role of a sequencer is, and lots of teams get confused about what it's supposed to be doing as well. So in a rollup, you have two different actors. You have the sequencer. They interact with the user. They take the user's transactions. They order the transactions for execution, and then they pass them on. So all they're doing is ordering. They're not executing. They know what the execution will be because they decide the order, but they don't actually do the hard work of convincing the bridge about what the database looks like. Then you have a set of executors. You take the order transactions, they execute them, and then they convince the bridge, oh, bridge, this is what the database looks like. So with that in mind, what's really nice about that architecture is that the sequencer potentially has nothing to do with the security of the system. If the sequencer goes offline, users can just take their transactions, send it to the bridge directly. It gets ordered for execution. Then you assume there's one honest executor out there who picks up the job and obviously executes it. So that's cool. The sequencer can be one actor, and it doesn't necessarily impact the fundamental security of the system. Now, there's some of the things in the short term they could do. They could just promise to include your transaction, and they don't. And that could have implications for these DeFi protocols. But what's nice is that you don't have to necessarily decentralize the set of executors. We don't need proof of stake Ethereum. We don't need 500,000 different sequencers. And then if you think about it from that architecture, the sequencer's job is to offer a fast path and the user experience, and to make sure that the user gets the best experience when interacting with this rollup. And that comes down to like one part of that is latency. Who do I talk to? The user needs to know, where do I send my transaction? The basic problem. The second one is what's already been alluded here is composability. If there's two different rollups, let's say the user wants to, take their money on Arbitrum and then send it over the Optimism, do a transaction there, and then they bring the money back. In that case, there's a benefit to have a shared sequencer who runs on both systems, because then they can coordinate the transactions. I think personally, for me, that's a short-term solution until we have better bridges that connect the various rollups, and it can provide you asynchronous, or like hop protocol, I send the value over, I interact, and I bring it back. It's not immediately composable. Well, it is composable, but it's not synchronous. It's async. It may take 2 minutes versus a very nice promise that'll be done atomically, or as close to atomically as possible. And then I think when you think of the sequencer set, the goal is really just to make sure that you can make sure that the fast path is always available to anyone in the world, or to most people in the world. And that's really the goal there, is to make sure people can actually transact on the system that is credibly neutral.
Thank you, Patrick. I think we're running out of time, so we'll take one last question. So there's a question about what the future would be, or what you think or hope the future should be. So what are your predictions, or what are you hoping for the rollup space to achieve in the next 2 or 3 years? Stephanie, you want to go first?
Yeah. Wow. Sometimes it's so hard to envision what's going to happen even in a month from now. Everything moves so quickly. But I'm really excited to see a lot of these projects launch on mainnet. So I think, Celestia being a huge project that we're all expecting. And then, all of the shared sequencer networks that are going to come online as well. And just, with the growth of rollups as a service, which are, getting also a lot more established, just all the different plethora of rollups we might see. In 2 to 3 years, to be honest with you, I can't exactly tell you exactly how it's going to look, but I feel like there's going to be a lot of lessons learned We're going to discover some issues, things that didn't quite work the way that we thought that they would in theory, and we're going to correct them. And I'm just excited to, be a part of this journey and, documenting and seeing, where we all go. It's just super exciting.
Medha?
Yeah, I have a couple. I guess for one, I'd love to see, I kind of mentioned this, but a bigger focus on value capture. So if we're right about the roll-up centric future, roll-ups are going to be in the flow of so much value. And so how are they going to be able to capture that value? So that kind of requires effort done both around shared/decentralized sequencing, around like thinking about like incentive structures, et cetera. So I'm excited about that. And then the ZK space is moving way faster than I think any of us really expected. So I'm really excited to see a lot of those kind of come on mainnet in the next year or so. And then I'd love to see more out of the box models for specific use cases. I think a lot of the roll-up as a service companies are going to be driving this. But let's say I'm a game, like I want something like so easy to use that it's like specifically built for like high throughput, high take rates, etc. And it's just built for this use case. I think you can do that for a lot of different use cases. So I'd love to just see like developer experience getting better around rollups. And then the last one I'll say is around kind of greater emphasis around like bridging UX, kind of like what Patrick was talking about, like how can we get atomic interoperability between all of these connected rollups. But yeah, I'm really excited about all of this. I feel like the roll-up space specifically has a lot of engineering bandwidth behind it right now. Some of the top projects working on it, which is great. I think it's proliferating a lot faster than any of us thought.
Patrick?
Yeah, maybe some concluding thoughts. So I think what's important is that we can see the results today of how roll-ups are going to sort of look in the future. But it's important to remember this has been a very long journey. It sort of started in 2014 with the original sidechain paper for Blockstream. They don't use the word bridge in the paper, but they were basically trying to build a bridge where I could take my Bitcoin, lock it up, put it on a sidechain, transact there, and then bring my funds back. And it's taken a very long time to solve a lot of theoretical issues and, of course, practical issues as deploying these systems. They get to where we are today, where there's maybe 4 to 5 big roll-ups, you could say, or 6. I mean, let's say 5 now that are probably live, So then the question is, where do we go from here? And I'm really cautious that, like, this sort of resembles the beginning of, computing in the 1940s. There's a really famous quote by Thomas Watson from IBM, where he basically says, you can't foresee a world where you need more than 5 computers. And today we have about 5 roll-ups. It's very, very similar dynamic here, isn't there? And to me, I definitely foresee the idea that rollups can just be an SDK that anyone can deploy, and it will protect the users of that system. I mean, what you're really doing is that you're removing this power balance between the user and the operator. Today, the operator holds all the power. And because of that, and that the requirement of trust in the operator, it creates a lot of friction for people to interact and to transact and work together. But once you remove that power dynamic where the user is equal to the operator, and there's no longer this power dynamic that you don't have to trust the operator of a system, you just have to trust the platform itself. Then it's very easy for people to just transact on the internet. For example, I could lock my funds into this Chinese website that I can't read. I could then play their horse racing game. Maybe they rigged the horse racing game and they beat me, but at least I know if they go offline, I can always get my funds back out. Where today, there's no way I would send my money to a Chinese website because I just don't know the operator. I have to trust them. So once we can remove that power dynamic, then yeah, this is going to flourish. It's going to be hundreds of thousands of deployments of rollups because it's just a better way to build an open database and protect users. And if anything, when you think of the regulatory sort of environment now that the US finds itself in, sometimes you sit there and think, are we the bad guys? Are we actually doing something really wrong and the regulators are correct? But it's wrong. It's the opposite. It's sort of, we're building systems that is a regulator's wet dream. They're so transparent that there's the financial information is all there on the blockchain. And we're building systems that protect users. At the very heart of it is just to protect the user when they transact. So yeah, I'm very, very bullish on the field, obviously, and hopefully for the right reasons. But yeah, they're sort of my views for the future.
Of course. Well, with this, we will end this panel. Thank you very much, Stephanie, Patrick, and Medha for your time. It was great having you all talk about rollups, rollups and service providers, and other related topics. Hope you all enjoyed this conversation as well. Thank you very much.
Thanks, everyone.
Yeah.